My name is Stefan Wrobel. I'm the director of the Fraunhofer Institute for Intelligent Analysis and Information Systems in St. Augustin. I'm also a professor at the University of Bonn. And I'm heading the Fraunhofer Alliance Big Data, 25 institutes that are focusing on the issues of big data, but which span the arena from computer science, from information technologies, all the way to the application areas such as production, logistics, and life science. And it's pretty exciting for me to have this interview here in the context of the ISC conference, where the question of supercomputing, of high-performance computing is an issue, because obviously big data and high-performance computing have a lot of meeting points. There is, of course, applications where there is little data and a lot of computing. There is applications where we have a lot of data and little computing, but most of the time today, big data is not just about collecting data. Big data is, of course, about analyzing these data, and that almost always results in enormous challenges into the processing, into actually running the analytics on actual computing architectures, doing that in the time frame that is available and doing it at the cost that is available. Why is that so? Basically, big data is a term that has become very popular, and it's highlighting a trend that we've seen for a number of years now. And this trend is to ever more data. We're hitting the zettabyte age now. We'll run out of prefixes to use for the amounts of data, but not only in general, but we're seeing this in companies. So it's not that they are out there somewhere, the data, but the data are there in companies, and companies are realizing they need to make use of that. All the studies show that the general impression that we're getting, that companies who will not invest enough into their digital transformations, that they will have problems. And we now see that studies show it actually is so. So we're seeing an enormous interest in analyzing this data in companies, and that creates challenges in particular for analytics. And an interesting development that we're seeing that is also of relevance here is the open data, linked open data development, because that adds to the amount of data that is available and also adds to the challenges, because it means that companies now process not only what's available internally, but also need to work on the things that are available externally, because this gives us basically enormous opportunities. At the Fraunhofer Alliance Big Data, we've basically noticed that all of this translates into big potential, but also challenges for companies into putting this into practice. So there's, of course, the technical challenges. Once you know what you do, you need the right architecture, you need the right partners, the right vendors, the right software to do all of this. But we're seeing that actually it's wise, and that would be an advice also, to step back a little beyond the individual technical challenges, to first decide what are your data assets in the company. What data do you have? Which data could you be having? Which data could you get your hands on from external partners? And then decide how does it impact your business case? Because that, of course, is the crucial questions. Some people say big data is about better predictions. Some people say it's about better decisions. But for companies, ultimately, their life is about better business. Okay, and better decisions is only interesting if it leads to better business. So that's why we're advocating very strongly to look at the entire business case across the company. And that means to look at basically things that cut across companies, that look at the data in the entire company, and then only identify basically the showcases or the quick wins that you can go to when you want to actually be looking at big data. And I think that is an important message when you want to be investing in big data as a company today.
Okay, thanks. So if I understand correctly, what you mean with linked big data is, for instance, that today you have things like OpenStreetMap, which collect a lot of data. In the Netherlands, you have a database with all the properties that are there. There are 8 million structures in the Netherlands. You have that data available. And if you think about that, you could combine that in certain ways. Is that what you mean with linked open data? But then
exactly. There's a lot of well-known resources. You mentioned OpenStreetMap, but there's also literally hundreds, thousands, or maybe 10,000s of lesser-known resources, since more and more institutions are actually publishing their data. The interesting point, however, about open data is that it's not, as many people think, about governments publishing basically public data, but linked open data is a paradigm of bringing data together. It is easy to bring data together if you are in control. If you can structure the world the way you want to see it. For example, your own department, you usually can enforce a common data model that everyone has to adhere to. And if they don't, there's going to be punishment. But that's not the way the world is right now. Business is a network business now. Even within a company, you usually don't have control over all the things that are being done across the globe in your enterprise. You cannot do that, or if you could, it's too expensive. So linked open data is a paradigm that also allows companies to network their own data with each other without having to invest too much. So it is both a technology that can be used to save cost and to do things better. And at the same time, it's an asset that can be brought in from outside to help a company do things better. And I think it will be needed in many circumstances to make use of big data. Because if we're honest, big data is not something for only the big corporations. We know that Google, of course, has big data. So does Facebook. But most of the economy, even though sometimes it doesn't appear like that, most of the economy is not Google, most of the economy is not Facebook. For example, in Germany we have very, very big strength in the area of production, manufacturing, all these classical strengths of Germany. But there we're also seeing we have big companies like Siemens, but even they need to partner up with others. But we have lots of smaller companies, leaders in their segment, world leaders in their segment. But my prediction is that for some of them, their own database may not be large enough to actually reap the benefits. And for them, there is an enormous potential in cooperating with others, because as soon as they do, if you add two data sets together from two partners, then the sum is not 1 + 1 = 2, but the sum is probably 1 + 1 = 10 if you do that.
Okay. And is there already something that can be said about the technologies that will be used for that? Will that be RDF and RL, or will that be something else? Or?
Exactly. You've mentioned some of the important keywords. There's, of course, many more that could be mentioned here, but the basic technologies that are used here, fortunately, are not extremely technologically complex. You need to master them, you need to know how to use them in the right way, but I think it's a benefit that they're not over complex, but that they are relatively simple. That's exactly why they are also relatively cost effective. They have been designed for a world of heterogeneous data, and that is their strength.
Okay. Thank you very much.
Okay.